Okay, so we're doing 3 units on something called a quadratic, and the graph of a quadratic is called a parabola. So today we're looking at parabolas specifically. In grade 9, you focus on linear relations. So everything is a straight line. And you talk about the properties of the straight line. So just that last page. What are the properties of a straight line? We've talked about that again this year. Y equals mx plus b. Like, what are the properties that you focus on that everything in grade 9 ties back into? Somebody give me one of them. Slope is one of them. What's the other? Y-intercept. Everything with a linear relation boils down to slope and y-intercept. So if you know the slope and you know the y-intercept, you know everything about that function, about that relation, that linear relation. It's very simple because there's only those 2 properties. And they can change, and that makes the line tilt back and forth and move up and down the y-axis, but that's it, right? So it's fairly straightforward. And then you do word problems, and you graph them, and you write equations, and you manipulate equations, do all those things. Well, we want to be able to do all those things with all kinds of relations, not just linear ones. So in grade 9, you talk about linear. Grade 10, we spent 3 units talking about quadratics and all the skills that go together with them. And grade 11, all of a sudden it explodes, and you do like a whole bunch of different relations. The same thing in grade 12, and it's even more complicated. Okay, but what you're going to notice is, right off the bat, quadratics are quite a bit more complicated than linear relations. Okay, grade 9, they might have been a challenge, but you guys are experts at that now. Think about how easy it is to find the equation of a line, like a right bisector or a median. You're pros at it, right? We have been practicing that for the last little while. You get a point, you get the slope, sub it in, come up with the equation. That was the hardest thing you had to do in grade 9. And now it probably seems super easy. Okay, so parabolas will get there, but they are more complicated. If you look at this, oh, that's not turned on. If you look at this shape right here, you can tell right away that it has a lot more complications to it. And just like a linear relation, if I change the y-intercept, I'll change the look of that relation. Or if I change the slope, I'll change the look of the relation. Same thing with quadratics and their graph, the parabola. I can change all different things, like numbers in their equation, and make this thing look really different. Okay? And so what we're going to spend this unit mainly focusing on is the properties and what the graph kind of looks like and why. So that's what's coming for this unit. So there you go. There's a parabola. You want to get to know the shape. You want to know, like, it has a very particular shape. We're going to just spend today drawing some, basically, and trying to get a sense of what their important properties are. And so as you're drawing them, you want to get a sense of their shape. You don't get to just get a ruler and make a straight line. They're curves, so we have to draw it freehand, which can be tricky. By the way, everybody should have a pencil to do this. If you don't have a pencil, get a pencil right now, borrow from somebody or something. And then when we start drawing them later on, like tomorrow and the next day, you probably want to have a few colored pens, like a pencil, and then maybe a green, a blue, and a red pen. If you can get your hands on those, they might help. Okay. So we're going to use pens eventually, but you've got to be careful because when you graph with a pen and you make a mistake, everything kind of falls apart. Okay. So you want to get a sense of what the parabola looks like so that you draw it the right way kind of every time, and you don't do anything weird with it. It doesn't look like a V. It's more like a U because it's curved, but it's still not quite like a U. Like, it has a very unique shape. Okay, and that's what we're going to try to get a sense of. All right, so here's the list of important properties that we need to know what they are, how to find them. Like if I just gave you a parabola, not today, not tomorrow, but eventually, maybe by the end of this week or early next week, you could highlight all the important properties without this list. Like you could come up with it yourself. Okay, that's where we're going. You want to be able to look at a parabola and kind of know all the important details. The important details will be answers to questions. They'll help us understand the relation. They'll help us graph it. They'll help us do all kinds of things. So we got to know what these properties are. First one, and possibly the most important, is called the vertex. Okay, and the vertex of this one is right here. So you want to write that down. Everything I write down, you want to write down so that you've got it on your sheet so you can refer back to it. The vertex is a very important point. You've probably already guessed. Every parabola will either start from the top, come down, change directions and go back up, or it can, as we'll see, start at the bottom, go up, change directions and come back down. And that exact point where it changes directions is the vertex. Okay, so it's an important point. The vertex is one that everybody will know really well. The growth pattern, we'll get to this a little bit more in a minute, but the growth pattern has to do with the reason why this looks the way it looks and what makes it a quadratic relation. Okay, so first of all, well, we're going to see that in the next one. So let's come back to growth pattern. We'll look at it after. The zeros, or the x-intercepts, here they are. So they are where the parabola crosses the x-axis. The y-intercept, this one doesn't have one, but if I continued on, it would eventually. So the y-intercept, we all know that. You know that from linear relations, is where it crosses the y-axis. Okay, so that one should be familiar. What's not really the same is in a linear relation, it's the plus b part. It's not really going to work out the same way for quadratics. It's not just like the y-intercept is what you plot first. That's not how these work. Okay, so same idea, but very different for quadratics. The axis of symmetry. So the axis of symmetry, what does the word symmetry mean? Divides it in exactly half, not in a special kind of half where like both halves look identical. That's what symmetry means. So some things are symmetrical and some things are not symmetrical, right? You could even imagine all the shapes we worked with, like a circle. If you cut it down the middle, like along the diameter, it would be symmetrical. A square would be symmetrical along the diagonals, or if you cut it in half vertically or horizontally. But a rectangle wouldn't be symmetrical if you cut it along a diagonal, but it would be other places. Triangles might be, might not be, that kind of thing. So that's like symmetrical. Some things are, some things aren't. Parabolas always are. And here's the axis of symmetry. It goes straight down through the vertex. It's a line. Notice that you can't draw any other line that would cut it in a symmetrical half. If I tried to draw a line like this, and I folded the bottom up onto the top, that's not going to fold onto itself, right? It wouldn't look like that. Or if I cut it here, then it's not going to fold onto itself. It's not like a mirror image. But right there, it's a mirror image. Okay, so that's axis of symmetry. A lot of people struggle with the axis of symmetry for some reason. The optimal value, the maximum or minimum. What's the minimum value of this graph? It happens at the vertex, exactly. So this graph will never go below that point. It's -4 in this case, but it could kind of be anything. So this one is a minimum of -4, and that's the optimal value. Sometimes we call it the optimal value. Sometimes we call it the max or min. This graph does not have a maximum. What do those arrows on the top mean? It goes on forever. It'll never hit a maximum. It'll always keep getting bigger. We can't draw that. It would take forever if we tried to draw, but it doesn't have a maximum. It keeps going. So the arrows in mathematics are actually important. People leave them off graphs all the time, but they're actually really, really important. Communicate something important. The direction of opening. Which way does this open? Does it open up or open down? Like, this is an easy one because you have a natural sort of sense of it. Andy, what do you think?
Probably opening down.
Opening up. Because it, like, the opening, where it opens, points up. That's okay. So this opens up, direction of opening, it opens up. And domain and range are two that we're going to get to in a second, but they're on the list and they're important properties. So if I give you a graph, you have to be able to identify the vertex. You have to be able to identify the zeros or the x-intercepts or the y-intercept or all of that stuff just by looking at the graph. Sometimes, like in the homework, I'm not sure if how many questions might be like this, but sometimes graphs like this one doesn't have a y-intercept on the graph. If I continued, it would eventually have one, right? Because this arm of the parabola is going to keep going up and keep going that way forever. Okay? So it will eventually have a y-intercept, but I don't know what it is. So if in the homework that ever happened, then you just, like, don't worry about it. You can't figure it out. You should see x-intercepts usually. Ben. This graph? No, not the type that we're going to look at. You can obviously draw a shape. Good question. You can draw a shape where you take this parabola and you lie it down on its side. You can draw that. It's a very different kind of relationship for reasons that might be more clear in sort of grade 11 and certainly in grade 12. But the ones that we look at only open up and only open down. Okay. There's a few things there that you can read through. Some of it is just regurgitating what we've already talked about. See, parabolas can open up and down. The zeros are also called the x-intercepts and the roots and da-da-da-da. You can read through it on your own. It's really just a summary of what we've just talked about. Okay, so if you need to know what the optimal value is, if you forget, it's written there for you. All right, couple of definitions, and then we're going to try one of these. Usually we don't just point to the vertex. We identify its coordinates, right? So that's what we're going to do. So the domain and range are two terms that we use to talk about the nature of different kinds of relationships. Okay? And for linear relationships, they don't have a lot of use, so that's why you probably haven't heard of it yet. But domain and range in other kinds of functions, and again in 11 and 12, you see this even more. It helps us talk about what the relationship is like. Okay? But what you need to know right now is domain is all the possible x values. And range is all the possible y values. So for example, if I just go back and look at this graph, just think to yourself, what are the possible x values and what are the possible y values? Like, can x be 3? Yeah, it is. It's right there. It's on the graph. Can x be 2? Yeah. Can x be 0? Will this graph eventually reach x equals 0? Right. Will it hit 10 going the other direction? Will it hit negative 10? Eventually. It'll be really high up, but it will eventually get over to negative 10. Is there any x value that it can't be? There isn't. X can be anything. It can be 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, anything. So X can be anything. That's not how we say it. There's a special way we write domain and range, but that's what it means. X can be anything. There's not a number that X can't be. What about Y? Can Y be 0? There it is. Can Y be 5? Yep, actually it's 5 in 2 places. Can Y be 100? Yeah. Natalie, what do you think? Can you come up with a number that Y can't be? -6. Down here. This graph will never hit -6. It will never hit -5. It'll never hit -4.5. It's going to come down and touch -4 and go back up. So we have a special way of saying that, but basically what we're saying is this graph, this one in particular, not all parabolas because they're all different, this one in particular, the y's can be anything -4 or bigger. There's no maximum. It'll go on forever that way, but it'll never go below -4. You see what we mean? We're describing the nature of the relationship. So the notation, these are called brace brackets. You have to use these. They have a special meaning in mathematics, and they are how we talk about sets of things, which is what domain and range is. They're also called squiggly brackets. They're like, but the formal name is brace brackets. It's a button on the keyboard. I'm sure you've seen it. They can be a little bit tricky to write, draw the first time you try, but give it a try. Yeah, like that. We have this symbol, which is kind of like a capital E, except it's rounded. And it means element of. We have this symbol, which is a capital R, but it's called a double bar R. And again, like this is a really important symbol in mathematics. So some people will say, why do I have to write it with 2 bars? Why can't I just write it? Because that's not what we do in mathematics. This is a hugely important symbol. So we always write it with a double bar R when we're talking about domain and range. And it means real numbers, as opposed to imaginary numbers. What else? We have a straight line. That means such that. And you probably all already know these. This means less than or equal to. And this one means greater than or equal to, or equal to. And it depends on which way it's pointing. The big N points at the big thing. So whichever way it's pointing, but that's how you would read it. You always read it left to right, but we're going to also try to write it left to right. So you'll see when we come up with an example. Okay. Okay. I think that's everything for the notation. So I hope you have that copy down in case you ever have to look back at it. It is a picky thing, but it's the way that we do it. Doesn't change. Grade 11, grade 12, moving forward, you always have to do it the same way. And if you just practice a little bit and get used to it, it's not a problem. Okay, let's take a look at this. So I want you to do it independently. We're going to take it up as we go, but what do you think the vertex of that graph is? Don't shout it out. You don't have to. You can if you want. Okay, who can tell us what the answer is? Dylan. -3, -4. How many people got that? How many people wrote it like this with brackets and a comma properly, like a point? Very good. You have to. Again, like we talk about all different kinds of things. And so notation helps us know what we're talking about. That's a point. That's an xy coordinate. Where are the x-intercepts? Very nice. So I'm going to list them as points. That's the safest way to do it. I'm going to show you a couple things. So -5 is the x value and 0 is the y. 0 is always the y value of an x-intercept, right? And -1, 0. So I listed it as 2 points. That's the safest way to do it. If you just listed it as 2 numbers, you would get away with it. If you did this, -5, -1, that's wrong. You get 0 for that. That's 1 point. That's not 2 things. For me, some teachers might be pickier. For me, -5 and -1, like that'll cut it. But I would say listing it as points is always safer. Where's the y-intercept? We can see it on this one. Somebody else. Trinity, what do you think?
0, 5.
Very nice. Right, there it is right there. So 0, 5. Where's the optimal value? We're going to say what it is. So is it a max or a min? And then where is it? What's the value? Natalie? Min of -4. Very good. Direction of opening? It's an easy one. Very nice. See, you redeemed yourself. This is a tricky one, axis of symmetry. Where does the axis of symmetry occur? Ben? Yeah, at -3, but you're exactly right. It's x equals because it's an equation. The axis of symmetry is a line. And for some reason, some of you will never want to write it that way. You're always just going to write -3. But that's not what the axis of symmetry is. It's a line. So again, it's a technicality, but you have to say x equals. If you just push yourself to be careful, you get in the habit, then it's done. For other things, we don't say. Like we don't say y-intercept is y equals 5. Don't say that. Because that looks like an equation of a line. X equals -3. It's an equation of a vertical line that goes through -3. And if I was to draw it, it would go like this, and it cuts it in half. It's not a point. It's a line. Does that make sense? Growth pattern. Okay, so this is where we haven't even talked about the equation of these graphs yet. But what we're going to do is the growth pattern starts at the vertex. And first we go over 1. And how many do I go up? 1. Then I go back to the vertex and I go over 2. And I go up 1, 2, 3, 4. Then I go back to the vertex. So over 2, up 4. Then I go back to the vertex and I go over 3. And I go up 9. That's the growth pattern for this relationship. It can change. It won't be the same for every parabola. But there is a consistent relationship. Does anybody see the pattern? What's the pattern? Don't shut it out. What's the pattern between the overs and the ups? Sarah, what do you think? You square the overs to get the ups. Right. 1 squared is 1, 2 squared is 4, 3 squared is 9. How many people saw that? How many people noticed that? And guess what? The equation of these is y equals x squared, which is I take the overs and I square them to get the ups. I take the x's, which tells me how far I'm going this way, and I square them to see how far I go this way. That's what a quadratic is. That's what makes a parabola. So there's your relationship right there, that growth pattern. Ben. Every parabola is the squared thing, yeah. But if I add numbers to that equation, this could look different in the end, but thinking about that growth pattern is going to help us graph them and think about what they're like.
So if it asks you like for the growth pattern, you write like L1.
Yeah, exactly. Over 1, up 1. Over 2, up 4. Over 3, up 9. For now, we're looking at like just finding those points on the graph. I think for today, yeah, there won't be too complicated. Did you have another question?
I was just gonna say, like, does every parabola have the same?
Not quite. No. We'll talk about equations a little bit in a minute. We're going to look at them more detail tomorrow and start examining them more in detail tomorrow. Right now, we're kind of just getting used to what a parabola looks like. And then we're going to, because when we start talking about the equation, we have to already have a sense of like the vertex and stuff. So we're starting with that. Okay, domain. So here's where we're going to write a domain. It's going to be really weird. What are the possible x values? Remember we talked about this. Tell me in your own words, for that parabola, what are the possible x values? Is that x values or y values? That's y values. Very good. So that's fine. Let's talk about the range, because the range is the possible y values. So the range says, in English words, like in plain natural language, it can be anything from -4 up. Perfect. That's how you want to think about it. This graph will never go below -4. It can be anything from -4 up. Here's how you write it. And it looks weird, but you get used to it if you just try. Okay, we start with an open bracket, a brace bracket, squiggly bracket. We write y is an element of the real numbers such that y is always greater than or equal to -4. And then we close our brace bracket. It's a formal process, just like if you were to write the name of a city or town or country, you would write it with a capital letter. So you have to say it this way. Let me repeat it again. It means y is an element of the real numbers. Again, that's a technicality. You have to write it this way, but it'll always look like that. So that part will never change. So don't worry about that. But sometimes you can talk about other relations where that's not true, so that's why that's there. Such that, and then here's the interesting part, where you have to dictate what are the possible y values. Well, y is always greater than or equal to -4, because -4 was that minimum value. Okay, so what are the possible x values? Yeah, x can be anything. That's what you mean, right? When you say x can be anything. So how do we write that? X is an element of the real numbers. That's it. That's the formal mathematical way of writing x can be anything. So I'm going to make a note of that. Here's my red note. X can be anything. And here's my blue note. Y is always -4 or higher or bigger, whatever you want to call it. Does that make sense? Look at a couple of patterns in here. Okay, so stop what you're doing and take a look. The vertex, -3. Where do you see that come up again? Axis of symmetry. Will that always be true? The axis of symmetry has to go through the vertex to be symmetrical. So that x value of the vertex will always be what this equals. What else comes up? The -4, the -4 minimum of -4, and the vertex value, y value of -4. Always going to be the same, right? There's kind of 3 different ways of saying the same thing. The fact that this says y greater than or equal to, and the fact that that's a minimum, again, those are linked. Does that make sense? They have to be. If this parabola opened downwards, which we haven't seen one like that yet, it would have a maximum value, and it would always be less than something. Right? So there's like connections there, and that's the kind of stuff that you want to be thinking about and trying to sort of make connections to over the next few days. Any questions? Okay, so here's what we're going to do for the rest of today, and here's what your homework is going to be. We're going to make a few graphs. So we're going to make one right now just with a table of values so that we practice drawing parabolas and so that we practice those properties, vertex and all of that stuff. Okay? So a table of values is a really nice skill. It's a basic skill. It's supposed to be easy, but sometimes you haven't done it in a long time, so you forget how to do it. We are going to do table of values today, but then never use them again. A table of values is not how we want to draw a parabola. It's really slow, really cumbersome. We're going to learn about parabolas so we can draw them more quickly. But for today, we are going to use the table of values. Okay? And like I said, it is a good skill that you need to know how to do. So how do I do a table of values? I look at the equation. It tells me the relationship. And in this case, I find my y value by taking my x value and squaring it. Okay, so I'm going to show the substitution a few times, but then once I get it, not every time. And here's a tricky part, which won't be tricky down the road, but today it might be. If you put -3 and squared it on your calculator and got -9, what did you do wrong? You forgot the brackets. This is -3 times -3, which is +9. And if you mess that up, you're not going to get parabolas. You're going to get something else. Okay? We're going to do a third column where we just summarize our points. So I've got a point -3, 9. Next one, -2 all squared. What's that? Shout it out. 4. -2, +4. -1 all squared. 1. So -1, 1. 0 squared. 0. So 0, 0. And then look what happens. What's 1 squared? Why would it be negative? Because the other one flipped. But think about it, this is 1 times 1. So what do you think it is? Yeah, just 1, right? Just +1. Very good. 1, 1. What's 2 all squared? 2 times 2, 4. What's 3 squared? 3 times 3, 9. Thank you. 3, 9. So look what happened. I put in a negative number. I got out a positive number. I put in a positive number. I got out a negative number. Again, there's your symmetry. Whether I put in -3 or +3, I got the same value. Right? And it's not always like 3 and -3 and 2 and -2. It's not always like that. But there is always that parity, that symmetry, where you get those two y values from two different x values. Does that make sense? You can see the growth pattern in here. I took the x's and squared them to get the y's. I took how much I was going over by and squared it to figure out how much to get up. That's a good understanding of this relationship. So now what do we do with this? We plot the points. So -3, +9, -2, +4, -1, +1, 0, 0. Where's my vertex? 1, 1, 2, 4, 3, 9. Put your pencils down for a second, please, and watch this. I'm going to make 2 mistakes, and then I'm going to do it correctly. Okay? And you're going to try to really concentrate hard so that you don't make these mistakes. This is what some people like to do. So I connect, so we don't use a ruler. This is a curve. We freehand it. So I come down like this, and then I come down like this, and then people go like this. That is wrong, and you will be marked wrong. Parabolas don't do that. But for some reason, people like to make them do that. I don't know why, but people do. They never curve back in. If that happened, that would change our domain, the possible values of x. They don't curve back in. They keep going out. But here's another thing they don't do. And this is the other thing that people like to make them do. Why won't that erase? We get here, it's a nice smooth curve, then all of a sudden it starts going like this. It's nice and smooth, and then we start going like this. You can go back to your People like to do this, I don't know why. Don't do this. What does the graph do? It just continues on in the same smooth curve.
Could you just put arrows?
You could just stop and put arrows.
Can you put it on like the point that if you're lazy?
No. It's got to go past the point. You can't put arrows on a point. You don't have to go very far past. This is important because this is what we do with relationships. What would it be if I put in 4? If I put in x as 4, what would I get for y? 16. Where is 16 on this graph? Way up high. So this guy right here should not cross that line until it gets to 16. So even if I kind of went like this, that's wrong. Because when x equals 4, it's not there. So what I would say is after you've kind of finished drawing, don't cross the next grid line. Just go like that in between the two and put an arrow. And if you do this and you kind of focus on this today while we're drawing just with the table of values, you'll get a sense of what the parabola looks like. You always draw it like that. Parabola is a really special shape. If I throw something, it follows a parabolic path. Your satellite dish is parabolic. There's a whole bunch of things in the world that follow parabolic relationships. It's a really, really, really important relationship. Has a really special property. Okay, let's try another one. This one's a little bit trickier. I'm going to let you try it. We'll try the first one together. So I sub in -4 plus 1 all squared minus 2. Like I'm going to do this in steps, but I would suggest you do it on your calculator so you can get it done in one step. What's -4 plus 1? -3. So that's -3 all squared minus 2. What's -3 squared? 9 minus 2, which is 7. So what's my point? -4, 7, and I can plot that. -4, 6, 7. I did that. -4 plus 1. It was in the brackets. That's what got me the -3. Let's do one more together. -3 plus 1 squared minus 2. So -3 plus 1 is -2. -2 squared is 4. 4 minus 2 is 2. You don't have to do this in your head. So let's see, -3 and positive 2. You can use your calculator for this. I encourage you to do it, but you got to make sure you use brackets in the right spots or do it in the right order. Okay, you try the next few. Adam, you had your hand up. Do you have a question?
No,
You were going to answer for it? Okay, cool. Okay, hopefully you got a few answers so far. Take a look. Folks, parabolas never look like other things. Now, if I don't graph the vertex properly, then it's hard to describe. Like, it might not look quite like this, but if you've got the vertex on the page, parabolas always look like this. You'll never have like one up here and then one down here, or like all of a sudden, hey, that one's way over there. That's weird. Oh well, that must be a different kind of parabola. No, they always have that pattern. So you should always be getting sort of your points on the same level. If you don't, you've made a mistake in the math. Go back and check your math. Okay, so now I'm going to draw my nice smooth curve. And I'm done. It's said to list the important properties. So I don't have a lot of room here, but I'm going to do that anyway. So the vertex is -1, -2. It opens upwards. The x-intercepts are a little bit tricky, but they're like -2.6, 0. So I'm just estimating, and that's fine. And maybe 0.40. The y-intercept, oh, that's an easy one. I can see that. It's -1, so 0, -1. It has a minimum of -2. The domain is x is an element of the real numbers. X can be anything. The range, does somebody want to try the range for me? X or y is an element of the real numbers such that you might first think about it in natural language and then convert that to the math symbols. What do you think about the range for this one? What are the possible y values? Ben, at the back, you want to take a try? What are the possible y values? What do you think? Anything above -2, including -2. Always including -2 in this case. Very good. How do I write that? Y is always greater than or equal to -2. Any questions? Yes. I estimated it. Sometimes you'll be able to see exactly where the x-axis or the x-intercepts are. Sometimes you won't, so I estimated it. So for this, that's good enough. What do you think? What kind would not have one? Very good. Yeah. So it can absolutely happen. And if you graphed one like that, then you would say none. Don't leave it blank. Say no x-intercepts. Any other questions? Remember what I opened today with? I said, can you take one of those and pass them around, please? Remember I said, this unit is nice. The next 3 units are nice because if you, cut all kinds of stuff off. I'll fix it. If you practice, you'll see the benefit. Like you will get this stuff. Okay, but it's still true that if you don't do the work today, it's gonna quickly get harder. If you don't have a good sense of what a vertex is and what all those properties are, it's going to be hard to do what's coming next. So it's really worthwhile to make sure you get this practice done. Listen carefully because I'm going to give you an instruction. Oh, the one thing I forgot here too, I don't know what's going on here. There we go. Was the growth pattern. So starting from the vertex, I went over 1, up 1, over 2, up 4, over 3, up 9. I want you to do, how many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that right? So let's say, do you need one more? You got to do 4 as a table of values. And then if you want to use technology to graph the rest of them and then copy the graphs so you don't have to do all the calculations, that's fine. As long as you know how to do a table of values, it is something you need to know how to do, then that's fine if you use technology to speed up the process to do some of them. Because otherwise it can be very tedious and this would take a lot of work. So what you should do is go to GeoGebra, that basic grid. Actually, let me show you. So here's what you would do. Let's see, blank grid, because we haven't quite done this before. Down at the bottom, you see there's a little input bar. So if you use the link, you'll be able to type in there, y equals x, and that little hat thing, which is above the 6, shift 6, is how you do an exponent. And there's my parabola. And then, but you're going to have to, you can't just like copy and sketch it. Like you're going to have to look for points. You don't necessarily have to plot the points, but there's one, there's one, there's one, there's one, there's one. So you're going to have to kind of find the points. There will almost always be 7. There'll be at least 5, so make sure you find at least 5 points that you can transfer to your paper and then answer the questions about vertex and such. Does that make sense? So do 4 on your own with the table of values by hand, and then you can do the rest with technology if you like.